guys, so let's do 3.01 practice 1. It's going to be kind of tedious, actually. That's okay. Okay. So we've got a 6 Newton friction force acting on a 1.5 kilogram book as it slides across the table. So we need to do a free body diagram. So first of all, let's start with gravity. And that's going to be 15 because 1.5 times 10 is 15. That's a cool G. All right, 15. I don't usually draw my 5s like that. Well, you guys know that. You know how I write. But it just seemed easier that way. Okay, we've got a 6 Newton friction force. I'm going to pretend like the box is going that way. Which means the friction force will point this way. It'll be a little shorter than that, but we're just going to deal with it. So the force of friction is 6. Oh, I'm going to put the 6 up here. Oh boy. Okay. And then there's no applied force. It doesn't talk about it. The only other force, it's sliding across the table, so we know that we have normal force, and that's going to be equal to an opposite of force of gravity in this situation because it's not moving up or down the table, it's sliding across it. And so that's going to be 15. And then the next part, the next part wants to know what is the coefficient of kinetic friction between the book and the table. So we know force of friction is equal to, I'm just going to write mu times normal force. Okay, so it should be pretty easy. We're going to just plug numbers in. Force of friction is 6, so that's equal to mu times our normal force of 15. We're just going to divide both sides by 15. Sorry. So we're divided by 15, if I could get this to work. Sorry, guys. Oh, boy. Okay, so we've got 6 divided by 15, so our mu, is 6 divided by 15, which is 3/5, 2/5, which is 0.4. And that's our mu, and there's no units on that. Oh. Okay, that's number 1. The next one, we've got a hockey puck that's gliding across the ice. So again, there's no talk of any sort of applied force here. We've got 170 grams, so I'm just going to add something in here. That there's 1,000 grams in a kilogram, which means you just move the decimal over 3 places, so 170.0 grams is going to be equal to 0.1700 kilograms. So that's the mass we're dealing with. So when we want to do force of gravity, we do 10 times this number. So we've got 1.7 pointing down. So force of gravity is 1.7. Oh boy. I don't think I'm getting better at drawing with this, but that's okay. It's also super lagging, so I can't even see what I'm writing. Okay. It's going across the ice. So we have normal force, and that's going to be equal to an opposite of force of gravity in this situation because there's no other vertical forces. Okay, and then again, I'm going to pretend the puck is moving to the right, so we have to do force of friction going to the left. Now we have to do some calculations before we can get that. So let's do that calculation. This time they gave us the kinetic mu. So that force of friction equals mu times normal force we're going to use again. Oh. And our force of friction is 1.7. That's going to equal normal force times our mu of 0.15. So that just means that our normal force is going to be 1.7 divided by 0.15. So let's see what that is. And that's 11 point, that doesn't seem right. What did I do wrong? Haha. Okay, kids. Clearly I'm not doing well. Okay, 1.7 is actually normal force. Hopefully you didn't rewind a million times and try and figure out why I was saying that. All right, 1.7 times 0.15. Let's do that. And we get 0.255. That makes more sense. So our force of friction is 0.255 newtons. Okay, I'm not going to write all that out. I'm just going to write force of friction up here. It's going to take me too long to write 0.0255. We're just going to say it's equal to that, and we're going to get rid of that random j. I feel like that j is there because I screwed up, so come on. You guys. Oh, there we go. The j's gone. I think we're good. All right. This one with Brian, you guys were struggling with a little bit. So what this says is Brian skates along the ice at 15 meters per second. After coasting in a straight line for 30 meters, he moves with the speed of 10 meters per second. So there was a lot of a struggle here. First of all, the word coasting means that he's not skating. He's just like standing, and like if you're coasting your bike, you wouldn't be pedaling and you wouldn't be braking. So when you're on ice skates, you can just stand after you've skated for a while. You can just stand and not move, or like not push with your feet, but you'll still move. So we've got Brian. We're going to draw his free body diagram. We're going to point his force of gravity down. And that's going to be his FG is going to be 400 because 40 times 10 is 400. Isn't this whole G equals 10 thing really coming in handy? Also probably comes in handy that people always weigh like some sort of even amount. And then normal force is pointing up. And that is going to be 400 as well. Well, whatever. Ooh. All right. And then assuming he's moving to the right, we're going to draw a force of friction in here. And we don't know what it is yet. We have to do a lot of work to figure that. Not a lot of work. Maybe you guys think it's a lot of work. That says force of friction. Okay. So next they want to know what was the work done on Brian. First of all, there's no applied force, again, because of the coasting thing. So anytime you see coasting, that means we're not moving our feet, we're not moving anything. The work done on Brian, so that's going to be our good old E1 plus W equals E2. And people were confusing this with like, what work does Brian do? That's different. He doesn't do any work, actually. He did work to get himself moving to 15 meters per second, probably. But he's not doing any work while he coasts, and that's what they're talking about. So obviously there's some negative work done on him because he slows down. So friction is the only thing that's doing work on him anyway. So we're going to do, he has KE at first, and this is going to be work of friction equals KE2. So we're going to have 1/2 40 times 15 squared plus work of friction is going to be equal to 1/2 times 40 times 10 squared. All right, I'm going to finish this up in the next video. Huh.